All right, let me get my focus in. Let me focus up real quick. All right, that looks good. All right, so we're going to deal with fundamentals of probability. So I will say that a probability, so when you're looking at probabilities, a probability is the likelihood that an event will occur. So it's the likelihood. Oh, I might not have spelled that right, but likelihood that an event will occur. Okay, so outcomes are the basic possible results of observations or experiments. So it's basic possible results of observations or experiments. And then I'll talk about an event. So an event, and then I'll sort of start going through these, okay? So an event consists of one or more outcomes that share a property or of interest, that share a property of interest. So I'm going to describe an event, and then I'll show you what would be the possible incomes. So for an example, I'm going to flip two coins. So I'm going to, what do you call it? Toss two coins. Tossing two coins 4 times. So let's look at the possible outcomes I could get. I could roll a H and a H, which would be a head and a head. I could roll a head the first time and then a tail the second time. I could have rolled a tail the first time and then a head. And then finally, I could have rolled 2 tails. So when you're looking at probabilities, you're looking at the possible outcomes that you want to look at versus the overall total outcomes. So, for example, on this example, if I wanted to find the probability, so I'm going to find the probability that one head and one tail will be thrown or tossed. How about that? So what's the likelihood that I could get one head and one tail by flipping 2 coins 4 times? So what you want to look at is how many combinations gave me one head and one tail. So if you look in here, my head tail or my tail head combination meet the criteria I'm looking for. So what you look at when you're looking for the probability, so your probability is going to equal the number of ways the outcome can appear, the outcome can occur, you're going to divide that by the total number of outcomes. So this is really why we was having you go over the fractions and decimal stuff in the support part of this class, so that you would be able to reduce your fractions when you get them. So here we go. The probability of my event A, which we'll just call this event A, is going to be the number of ways my outcome can occur. So out of the 4 outcomes, 2 of them had the criteria I was looking for. So I had 2 ways my outcome could occur. And then I had HH, HT, TH, telltale, which meant I had 4 possible outcomes. So 2 outcomes for what I needed out of the 4 outcomes. And y'all, if you notice, 2 over 4 will reduce to a 1/2, which means that if I throw 2 coins 4 times, I would expect half of those outcomes to have 1 tail and 1 head. Okay? And if you notice, the probability, your probability has to be greater than 0. So your probability has to be greater than 0, but it's going to be less than 1. So any fraction with the numerator is smaller than the denominator is going to be less than 1. And if you turn that into a decimal, 1 divided by 2 would give you 0.5. And 0.5 is definitely in between your 0 and 1. Okay? To get a 1 on that, the event would have to happen every time. And to get a 0, the event would have to happen none of the times. Okay? Okay, so let me turn my page for y'all. So the second way to find probabilities is what we call the relative frequency method. And basically, it's about the same thing. You're going to approximate the probability of an event happening by making observations and counting the number of times the event occurs. So for this one, your P of A, which is your probability that this event will happen, will be the number of times A occurred divided by the total number of observations. So that'd be the number of observations. This is often called the empirical method. And then the one I showed you with the coins there, would be my theoretical method, okay? Because in theory, I would look at all the combinations I could possibly have and figure out my percent that way, to where relative frequency, I'm flipping them coins and counting how many times it happened, okay? I might not get 1/2, but in theory or in this relative frequency, I want to be able to sort of estimate it or approximate it, okay? Okay, so in this example, I'll show you what we talk, the relative frequency, okay? This is the one where we actually want to count and flip. So I'm only interested in the number of heads when flipping 2 coins. So we're interested in number of heads when flipping 2 coins. So the possible events I could get would be 0 heads. I could get 1 heads, or I could come up with 2 heads. Okay? So we're going to suppose we did 100 coin flips. So suppose we flipped the 2 coins 100 times. So 0 heads occurred 22 times. So that means 22 times they had 2 tails on their flips, okay? They got 1 head that occurred 51 times. And then 2 heads occurred, what was that, 27 times. So all these flips added up to 100. So they want me to compare what I get on my relative frequency to what I got while go with my frequency we did on the 2 coins, okay? And we flipped them 4 times. Well, we didn't flip them all. We was doing, we was looking at the theory about it. We looked at the possible outcomes and then how many of them 2 outcomes that had head tails like we needed. So we did that theoretically. So now we're going to approximate what we would get. So we want to know, basically, 1 head and 1 tail would mean that you're getting 1 head. So theoretically, we flipped it, and 51 times we had 1 head. So our P of A will be the number of times that this occurred, which was 51, out of the total number of observations. Well, we flipped this 100 times. Okay, now I'll show you. If you tried to reduce that 51 divided by 100 on your calculator, you get 0.51. And then if you tried to turn that back into a fraction by hitting math, enter, you only get what? 51 over 100. So it does not reduce anymore. But y'all, I'm looking at that 0.51. Doing this by hand, we got a 0.51. When we did it by theory and figured out the 2 out of 4 outcomes, that was a 0.50, which is 1/2. So basically, our empirical method was very, very close to our theoretical method that we did a while ago. We got 0.5. This is 0.51, so it's within 1/100th of it. So you can see now, if you don't know the theory behind it, you can actually perform those coin flips and see what you're getting, okay? So we're going to look at Next, 3 approaches to finding probability. So the first method was the theoretical probability. And that's where we took the possible outcomes that we were looking for out of the total outcomes that were possible. Second, we looked at was the relative frequency. And remember, I also called that empirical. Ooh, empirical. I don't know about my spelling tonight, y'all. And that was when you actually performed the moves. You flipped a coin, okay? So here's the probability. When it's theoretical, you're looking at the outcomes on paper and figuring out all the possible outcomes. Relative frequency, you're actually doing it, and then you're comparing your outcomes with the total outcomes. Number 3 would be what we call subjective. Subjective probability. And subjective probability is just an estimate based on experience or intuition. So it's just an estimate based on experience or intuition. So say in the past you done this experiment and you came out with a 1 out of 2 chance of getting 1 tail and 1 head. Based on that experience, you could estimate your probability on any future events that you're doing, okay? So if you got 50% one time, you'd be pretty inclined to think that you would get that 50% every time you rolled them coins, okay? So y'all think about this. Just as we have a probability of an event happening, we also got probability. So probability of an event not occurring. So the probability that not A will happen is 1 minus the P that A could happen. So what we're saying, if there was a 50% chance or a 1 out of 2 chance that I would draw 1 head and 1 tail, there's equally a 50% chance that I will not get 1 tail and 1 head. I would get either 2 heads or 2 tails. So that's what this is talking about. The event not occurring is going to be 1 minus the probability of the event actually occurring, okay? So I'm going to show you an example doing that in a little bit. Okay, so let's see. Not much more, and then I'm going to go through some of them homework problems to show y'all what we got. So we're going to look at this next is making a probability distribution. And this is just a distribution that'll represent the probabilities of all possible events. So to make a property distribution, the first thing you're going to do is list all possible outcomes. So list all possible outcomes. And you can often use a table or figure to help you do that if you want. Second, identify outcomes that represent the same event and determine the probability of each event. And then third, make a table listing each event and its probability. Now remember, the sum of all these probabilities has to equal 1, okay? So if you got, and I'll sort of show y'all that with my 2 dice again. So let's see. We're going to make a probability distribution. So make a probability distribution. Oh, let me see what that question was. And I'm looking for a probability distribution for the sum of 2 dice rolled together. And then it says, what's the most probable sum? So what is most probable sum? So when we roll a dice, the possible outcomes from rolling a dice would be a 1, a 2, a 3, a 4, a 5, or a 6. And that's just rolling 1 dice, right? So that's the possible outcomes that could happen from each dice. And the same thing with the other dice. You can get a 1, a 2, a 3, a 4, a 5, or a 6. So what we're going to do now is figure out all the possible outcomes, and what they add up to, because we're looking for the sums of the 2 dice. So the first dice could be a 1, second dice could be a 1, which gives me a sum of 2. First dice could be a 1, second dice could be a 2, which would equal a 3. First dice could be a 1, second dice could be a 3, which would give me 4. First dice could be a 1 plus a 4, which would give me 5. 1 plus second dice being a 5 would give me 6. And then 1 plus 6 on the second dice would give me a 7. So that's all the possibilities when the first number is a 1. So what if I rolled a 2 on the first number and a 1 on the second number? That would add to a 3. I could roll a 2 and a 2, a 2 and a 3, a 2 and a 4, a 2 and a 5, and a 2 and a 6. So let me get my sums here. So 2 and 2 would be 4, 5, 6, 7, and 8. That's all the possibilities when the first number is a 2. What if the first number is a 3? I'm going to do the same thing, right? 3 plus 1, 3 plus 2, 3 plus 3, 3 plus 4, 3 plus 5, and 3 plus 6. So this one would give me 4, 5, 6, 7, 8, and 9. All right, so we're halfway through it, looks like. So let's do the 4s. 4 can be added to every number from the second dice as possible outcomes. All right, so let's add the 4s up. I get what? A 5, 6, 7, 8, 9, and 10. So y'all, we got to do the 5s and the 6s. So 5 plus 1, 5 plus 2, 5 plus 3, 5 plus 4, 5 plus 5, 5 plus 6. So y'all are sort of seeing that this statistics and this probability stuff has a lot of math in it when you're looking at these probabilities, okay? All right, so let's add these up. That'd give me 6, 7, 8, 9, 10, and 11. All right, y'all, finally, let's knock out these 6s. So the first one could be a 6, second one could be a 1, a 2, a 3, a 4, a 5, or a 6. So let's get our sums. That's going to give me 7, 8, 9, 10, 11, and 12. So I'm going to look at the probability and then the likelihood that it would happen, okay? So let's look at our sums. The smallest sum that I could be is a 2. It could equal 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. So let me pull that down a little bit. So these were all the possible sums that I got over here. Nothing lower than a 2, nothing higher than a 12. So now, how many times? So this is going to be the number of occurrences. How many times did I get a sum of 2? Well, if you look through here, the only time you got a 2 was one time. So the only way to get a 2 is rolling snake eyes. How many times could we get a 3? I got a 3 here, a 3 here, and that's it. So 2 times I can get a 3. 4, I got a 4, 4, 4, and then nothing here. So 4 could happen 1, 2, 3 times. All right, how about 5? I got a 5, 5, 5, 5. 5 can happen 4 times. 6, I got a 6, 6, 6, 6, 6. I got 5 6s. All right, now we should start getting higher numbers on here. Let's see, 7. I got a 7, 2, 3, 4, 5, 6. All right, 8. I got 1 8, 2, 3, 4, 5. So 5 chances to get an 8. 9. I got 1, 2, 3, 4 ways to get a 9. You see what's happening now, right? I went up from 1, 2, 3, 4, 5, 6. Now I'm sort of going back down. 10. You got 1, 2, three tens, which means I probably got 2 11s, right? Because there's no 11s up here, but I got 1, 2, and then 12 you had one time. So these are the number of occurrences, and over here we're going to put our probability. So first of all, we know how many times they occurred, but now to find the probability, we got to figure out how many total cases is there. So 1, 2, 3, 4, 5, 6. There's 6 for each column I got. 6, 12, 18, 24, 30, 36. There is 36 total occurrences. Okay? So to find the probability, we take the number of occurrences, divide by the total number of occurrences. So for the first one, the probability of getting a 1 is 1 out of 36. The probability of getting a 2 is 2 out of 36, but we can reduce a 2 out of 36 into a 1 out of 18. So that means if I rolled 2 dice 18 times, I'm probably going to get a sum of 2 one time out of those 18. Okay, the sum of 3 is going to happen 3 times. So 3 out of 36, that'll also reduce to a 1 out of 12. All right, next, the sum of 5 happens 4 times. So 4 out of 36, that'll reduce to a 1 out of 9. All right, we keep going, right? Sum of 6 happened 5 times. And unfortunately, 5 out of 36 will not reduce. Sum of 7 has 6 times. So 6 out of 36 will reduce to a 1 out of 6. So notice, 5 out of 36 will be equal to a 6. 6 out of those 36, or 1/6 of them, will be a 7. So when you're shooting those craps, remember, you're trying to get a 7. There's only a 1 out of 6 chance you're going to get a 7 on that, okay? But craps uses 7s and 11s, so once we figure out the likelihood of an 11 happening, then you'll get the total likelihood of you being able to get that 7 or 11 when you shoot that craps, okay? All right, so next, let's see, I got 8. 8 is going to be 5 out of 36, which will not reduce. 9 will be 4 out of 36, which reduced to a 1/9. So now you're sort of seeing some symmetry here. Sum of 10 happened 3 times. 3 out of 36 is 1/12. 2 out of 36 for 11 is what, 1/18. And then the likelihood of having a 12, which would be boxcars, 2 6s, happens 1 time out of 36. So the question, what is the most probable sum you're going to get? Well, which one's more likely to occur is going to have the most number of occurrences, which is definitely going to be the sum of 7 there, because it can happen 6 times out of those 36, okay? So that's what they mean by a probability distribution. You're going to figure out all the ways you can get the sums you're looking for, how many times they occur, and then you're going to find that probability. Now, you can also put these in decimal form, and when you add all these up in decimal form, which I'll show you. So let's see, what's 1 divided by 36? That's going to equal 0.0278. 1 out of 18 is going to equal 0.0556. 1 out of 12 is a 0.083. 1 out of 9 is a 0.111. Oh, what's next? 5 out of 36 is a 0.13. Oh, I'll go 89 on that. 1 out of 6 is a 0.1667. And then we know what's going to happen. 0.1389, 0.111. I'm just mirroring my top. 0.083, 0.05562, and then 0.0278. If you was to add all of them together, that would equal right around 1. Now, it's probably going to be a little off because I'm rounding my errors. But watch, I'll get really close. 0.0278 plus 0.05562 plus 0.083 plus 0.111 plus 0.1389 plus 0.1167 plus 0.1389. So I'm going back down now. 0.111, 0.083, 0.05562, and then I ended up with a 0.0278. So notice when I enter, 0.948 is really, really close to 1. But like I said, what's happening is I rounded off my answers. If I was to do my division and adding in one big, long problem, it would compensate for my rounding errors, and it would actually equal 1 right on the dot, okay? All right, y'all, so that's a probability distribution. Now, we didn't kill y'all with that on a test, okay, or the homework. So odds. Whoops, let me pull back up. I forget. All right, so odds, you know, they give you odds when you bet on stuff. Odds are a ratio of the probability that a particular event will occur to the probability that it will not occur. Okay, so the odds are going to equal P of A, which means the probability that the event occurs, over P not A. So this is the probability event occurs. This is probability event does not occur. So now when you in gambling, the term odds on generally means the odds against, okay? So here's the question about these odds. What are the odds of getting 2 heads in tossing 2 coins? So our odds is going to equal the probability that my event happens. But remember, when I toss two coins, I could get a HH, a HT, a TH, or a TT. Both tails, one tail, one head, one tail, two heads. They said, what's the odds of getting two heads? So to get two heads, I had one chance of getting two heads, right? So that would be 1 out of 4 chance to getting a head. So notice I'm putting the probabilities, not the number of times it happens. The probability of getting two heads is 1 out of the 4 occurrences. So what's the probability of not getting two heads? Well, the only way to get two heads was HH. The other 3 are not heads, so you would have a 3 out of 4 chance of not getting two heads. So to solve this, since you got a fraction divided by a fraction, you would turn that into a 1/4, change from division to multiplication, and then flip the second fraction so that you get a 4/3. So remember, when you divide fractions, we change to multiplication and flip the second fraction. So notice, 1 times 4 gives me 4, 4 times 3 gives me 12. But y'all, I can reduce a 4/12 into a 1/3. Now remember, if you're weak at reducing, punch it on the calculator. 4 divided by 12 is going to give me 0.33, but when I hit math, enter, it gives me 1/3. Now watch, you can also do this. 1 divided by 4 divided by 3 divided by 4. Oh, I didn't like that. Let me show you the better way. So on the calculator, what I would do to that is put the top and bottom in parentheses so that the calculator knows where your fractions are stopping. So parenthesis, 1 divided by 4, close parentheses, divided by parentheses, 3 divided by 4, close parentheses. So we hit enter, we get 0.333, but remember, math and enter twice, you get 1/3. So I wanted y'all to see that you got to put parentheses around these or you're not going to get the right answer when you do this. Because if you remember when I didn't put my parentheses, I wanted y'all to see I got a 0.208, not a 0.33333. So this calculator is nice, but when you divide fractions by fractions, put them in parentheses. Alrighty, so now there's going to be a few examples on your problems when they're looking for the different choices you can make. So when making choices, we find the product of all choices, okay, to determine the total number of choices possible. So what I mean by that, we're going to play with car license plates. Okay, so in Arkansas, license plates have, now I think now we got 3 numbers followed by 3 letters, right? So we got 3 numbers followed by 3 letters. What is the total number of license plate combinations. So what is the total number of license plates that can be produced? So I'm just looking just to see how many possibilities do they have using 3 numbers and 3 letters. So what we got to figure out is how many numbers would be possible. So let's look at the numbers. Numbers on a license plate can start at 0 and go all the way 6, 7, 8, 9. So I got 10 possibilities on numbers. So that's 10 possibilities. How about my letters? Well, let's see. How long is the alphabet? Because that's how many combinations I'll have on letters. So from A all the way to Z is 26 letters. So to find the total combinations, I would take all the possibilities for the numbers, and I had that 3 times, right? So I got 3 numbers, which will be 10 possibilities for the first number, 10 possibilities for the second number, times 10 possibilities for the third number. Then guess what? I got 3 letters. So I got 26 possibilities for the first letter. I got 26 possibilities for the second letter. And then I got 26 possibilities for my third letter. So my total possible combinations are going to be the product of all these numbers. So let me get down here, clear. So y'all, we're just going to start multiplying. 10 times 10 is going to give me 100. Times 10 going to give me 1,000. Times 26 is 26,000. Times 26 is already at 676,000. Times the last 26. And it looks like I'm getting, oh, that looks like 17, 5, 7, 6, and 3 zeros. So there is 17 million possible combinations they could run off of using 3 numbers and 3 letters. So that is well enough to do Arkansas, right? Because I think Arkansas's population is, what, 3 million or so? So, y'all, we'll never run out of license plate combinations in Arkansas. You could have 2 or 3 cars, and you still ain't going to run out of total combinations doing that. Now, over years, you might start running out. So what they do is they'll put the 3 letters first and then the number second, and they'll have another 17 million combinations that they can do with those license plates. All right, so I'm trying to see, we're getting close to time. So let me do some of these examples where they're doing the odds. So this one says the odds on, which is against your bet, are 7 to 5. If you bet $40, I think that's what I said. What I say? If you bet $40, how much will you gain? So it looks like what's happening is for every $5 you bet, you're going to win $7. So if you bet 5, you're going to win 7. But guess what? You didn't bet 5, you bet $40. So we sort of just set these up as proportions. So to figure out how much I'm going to be able to win, I got to figure out the difference from betting $5 as to betting $40. So what happened to that 5 to turn it into a 40? Y'all, they multiplied that by 8. So $5 times 8 gave me $40. So my bet was 8 times bigger than what I bet. So my winnings are going to be 8 times bigger. So 7 times 8 will give me 56, which means I'm going to win $56 if I bet 40. So what, about $16? Because you're not winning a whole lot on that bet, okay? Now, watch this. I'm going to show y'all what cross multiplying is about. To see that you got the right number here, 5 times that 56, so I'm taking that top times that bottom, that equaled 280. When I do this bottom times that top, I get 280. So that's how I know that's the right answer, because when I cross multiply, they both equaled 280. All right, so let me do one more of those. So I'm going to bet on this one. The odds on or bet are 5 to 4. If you bet $8 and win, how much do you win? So if you bet $8 and win, how much did you win? All right, so let's see. We bet 4 to win 5. So we bet 4 to win 5. So, Lord, we're making a whole dollar on this bet, right? For every $4, you're making $1. But we bet $8. So we bet $8. We want to look at what we're going to win. So to get a 4 to turn to an 8, you had to multiply that by 2. So 4 times 2 gave you 8, which means you're going to multiply the bottom by 2. And 5 by 2 gives me 10, which means I win $10. So y'all, that's a big bet, right? You bet 8, you won a total of $2, okay? All right, so changing the tune up again, just to get y'all good on probabilities. Suppose an urn contains 2 black marbles. So 2 black marbles, 12 white marbles, and 6 yellow marbles. If one marble is selected, so if one marble is selected, what is the probability that it's yellow? So what is probability that it is yellow? So basically on this one, we're looking for probability of it being a yellow. So I got to see how many chances did I have for it to be yellow. So what they tell me up here, we had 6 of those marbles as yellow. So 6 would be on top because that's the possible yellow marbles. And then we divide that by the total amount of marbles, which is 2 plus 12 is what, 14? 14 plus 6 gives me 20. So 6 out of 20 of them marbles were yellow. And then this was the possible total marbles. All right, so 6 over 20 will reduce. We can divide both of them by 2. So 6 divided by 2 would give me a 3 on top. 20 divided by 2 would give me a 10 on bottom. So if you had these 20 marbles in a urn or an urn, that means out of 10 of them marbles, if I pick 10 marbles, 3 of them are going to be yellow. Okay? Or I got a 3 out of 10 chance in getting yellow, which means I got a 7 out of 10 chance that it's not going to be yellow. It's going to be white or black. Well, y'all, this was the start on our 7A stuff. So we're not going to get real deep into probability. We just want y'all to see how they figure it out. Now, I did a lot of examples on the support that I sent, 7A. I did both the 7As on one video for support. And then you'll have this video for 7A for the MR. So I'm going to stop sharing this. And do y'all have any questions over this? Now, what I'm also planning on doing is either tomorrow, probably sometime tomorrow, I'm going to get the 7A homework for this section and go through all them problems and work them and make a video for that for y'all. But they're pretty much doing what I did, but I just want to, I don't know, this section ain't got a lot in it, and I wanted to work that one on the video. So look for that probably tomorrow or Saturday at the latest. Okay?
I got one question.
All right, I hear you.
Okay, do you have to reduce on the test, on the quiz, or on the homework?
Yeah, anytime you got a fraction that can reduce, you got to reduce it down.
Okay, all right.
So if you get a 4 out of 12, just punch that
Yeah,
up.
you gotta reduce it out. Go down to 2. Okay, 2 out of 2. It'll be 2 over 6.
Yeah, and then keep going.
Gotcha.
Okay.
Reduce all fractions.
Now remember, when you're doing that reducing, if you reduced a 6 over 12 into a what would I say, a 4 over 12, if you turn that into a 2 over 6, you got to keep going because 2 and 6.
Yeah, keep going because she'd be okay, yeah, because reduce the lowest because she'd been like a 1 over whatever.
Yeah, 1 over 3. Yeah.
Okay.
Yeah,
Yeah,
so
1 over 3. 1 over 3. Yeah,
until you can't reduce anymore. Okay.
To get to the lowest amount.
There you go.
To lowest.
All righty, so I'm going to quit.